Hi guys, it has been a while since I posted my last video. I have been really busy trying to perfect my fish tank aquaponic filter design. I tried to make this whole system very simple so that if anyone wanted to install one on their fish tank, they can just buy the kit and put it on without any modification to the tank. I have now 3 pending patents on this and a registered company. I hope that I can call for enough funding to start my business soon. I will talk more about this later in other videos. Today I wanted to come back with a video about the 3018 CNC again. Many viewers have been asking me if they should buy one of these 3018 CNC to make things out of aluminum. I've always advised them against it because I tried it on my first version of 3018 CNC that looked like this one and then the Pro version, and they didn't do so well. A few days ago Amazon suggested me something that caught my attention, that is this version of 3018 CNC. It has all metal frame that is made out of aluminum. It has bigger stepper motor compared to the previous version, and it also has 200-watt spindle, which is about 3 times more powerful compared to the 775 motor S spindle. And it also comes with other features such as limit switches, e-stop button, Z probe. And here in the description of the machine, the seller also claimed that it can mill copper, aluminum, and other soft metals. Now it sounds really interesting, so I decided to get one and try it out. Few days later I got this really big box. It's really heavy, so let me just open it. And inside I got smaller box, but it's still much bigger compared to the previous version of 3018 CNC Pro. Surprise! Another box! Well, let's see if there's another box inside. I think that 3 boxes are enough. Here's what I see inside. Acrylic plate. Another one. User manual. Platform. Oops. To my surprise, the whole bottom frame were already pre-assembled. More surprise for me, the X-axis and the Z-axis block also pre-assembled together. The spindle, it feels a lot better compared to the 775 motor. Spindle clamp. ER11 collet. Flat end mill bit. V-bit set. Another flat end mill single flute. Stock clamp. Z probe. Power cable. Power supply. I think it needs to be bigger to supply the 200-watt spindle. I think this is the offline controller. Some screw and wrenches. Controller board. USB drive. I think that's it. There's nothing else. Let me just put the boxes away. Let me just check the manual quickly, see how I should assemble everything together. This kit, it doesn't come with the 5.5 watt laser. I think because the spindle clamp is bigger compared to the old version, so the laser won't fit directly into the spindle clamp. After going through the manual and the components, I think I know how to assemble it now. There are 2 bags with 8 of the M5 bolts. One bag with the shorter bolt, one is longer. I will use this bag first with longer bolts. On the 2 sides of the frame, you will see these 4 holes here on each side. Those are to install the bracket. These 4 sliding T-nuts, those are to install the acrylic plate. You should tilt the frame forward like this, so the nuts will slide forward. Okay, slide this on. Align the holes. Take out the hex wrench, just come with the kit. Just tighten the bolt. You should leave the bolt a bit loose for now. Do the same with this side. Now you can tighten the bolt on both sides. I think that pre-making the holes on the side of the frame is really smart. That way the X and Y axes are pre-adjusted. These two axes are already perpendicular to each other. Now I flip the frame over. I will install the feet on the bottom of the machine. Next step is to install this spindle clamp. From the figure in the manual, I will align the two top edges together. I tighten the side that doesn't have the opening first. Slide the spindle in. This feels really heavy compared to the 775 motor. Now I can install the two acrylic plates on the side to prevent the dust from flying out. Next step is to install the controller board. The sliding T-nuts are already in here. All the limit switches are pre-installed. You only need to plug in the cables here. They are labeled Y limit, X limit, and I have Z limit. Plug in the Z probe, spindle cable, e-stop button, I have to arrange the wire for the e-stop button. I don't know why they make it so long. Cable for the stepper motors. I think that the spindle cable can be tied with the Z-axis stepper motor cable. You can also use the cable wrap that comes with the kit to wrap the two cables together. One thing I should change is the position of this stepper motor on the Y-axis. I think that this connector should be on this side. That way I can arrange the cable along the frame here so it doesn't block the stock when it's sticking out at the back of the machine. I will do that later. Also remember to connect this cable here with the two connectors. This is the limit switch cable for the Y-axis. And that's it. I'm done assembling the machine. That was really easy. I think that the two big blocks of the machine were pre-assembled help a lot. That makes the process a lot easier. The machine is also really heavy, so it's a lot more sturdy. Next step, I will clear up the table and test all the movements of the machine. This is the power adapter that comes with the machine. It is 24 volt, 10 amps. So it can provide twice as much power compared to the previous version of 3018 CNC. I think that it will be more than enough to run these three bigger stepper motor and also the new spindle. I just turned on the machine. Now I will try to move all the axes. I will use the offline controller to test. all the axes were moving correctly, only that the spindle is turned in the wrong direction. I think that the wires were reversed, so I will try to reverse the wire and test it again. I checked the controller board at the back here. The wire is actually reversed. I will use a small screwdriver tip to push the pin out. Okay, let me just plug it back in. Turn on the spindle again. It turned in the right direction now, so it's all good. One thing that I noticed that the limit switch didn't stop the axis from moving over the limit. So I think that the limit switches haven't been enabled yet on the controller board. So let me just connect this machine to the computer, enable the limit switches and also the homing cycle. I will configure the limit switches very quickly. If you don't know how to do it, just have a look at my previous video. The link is right here. Next step, I will try to mill something out of aluminum just to see if this machine can do it. For the next step, I will use Fusion 360. I wanted to make some bracket out of aluminum to build a table frame out of aluminum extrusion bar 2020 series. So I will make a sketch very quickly. $60, 45 degree, 20, finish sketch, extrude. The aluminum sheet that I will use have the thickness of 2 mm. Now I will have to cut some holes. One hole right here, one around here, one around here, one here, one here. Okay, distance 20. Okay, that's it. Now I go to manufacture, create a setup. I always choose the origin here. That's my preference. You can choose any other point if you like. I will put 5 here and 0 on top. And click OK. Now I will have to cut those holes out. I will use 3D pocket clearing. Select the tool. The CNC machine kit came with 2 flat end mill bits. One has 3 flutes and one is single flute end mill. I like the single flute end mill because from my experience, to mill aluminum using high-speed spindle, single flute end mill is better. So I create a new tool, flat end mill, cutter, number of flute 1, diameter 2 mm, sharp 1/8 of an inch. I just enter all the parameters of the bit just came with the kit. I will put 20, 15, yeah, put 10 and accept. Not yet, I have to edit more cutting data. Here the maximum speed of the spindle is 12,000 rpm. Same here. Cutting feed rate. To cut aluminum I will go very slow. The machine seems to be a lot sturdier, but still it's not very powerful. Only 200 watt spindle. I will go 400 millimeter per minute. Ram feed rate, I will go slower, 150 millimeter per minute. Plunge rate, very slow. Let's just go 100. Disable and accept. And click select. Okay. Machining boundary selection. I will choose this boundary. It will include all the holes in this boundary. To center inside the boundary. Yeah. Put 2, 4, and -0.5. This is to cut all the way through the bottom of the stock. Tolerance, let's say very precise. Maximum roughing step down. As I said before, the machine is not very powerful, so just go very slow. 0.4 millimeter maximum roughing step down. Stock to leave. I will leave it a little bit. And axial stock to leave 0. The shortest path. This I will reduce a little bit, 1.5 or even 1 degree. Ram clearance high, 0.4 millimeter, seem about right, and I click OK. Okay, look good. Now I will do a smooth thing to make the edge really smooth. So I go 2D contour. This is the reason that I left a little bit of the stock for the 2D contour to smoothen it. I go a bit slower, maybe 200 to make it very smooth. This I can leave it. Select contour, select the bottom contour. Maybe 2, 4, 1.5, -0.5. Multi-depth, I will go 1 millimeter. This I have to reduce it, 1.5. This must be equal or smaller than this number. Then I click OK. Next step, I want to cut the piece out. To do it safely, I will do first an adaptive clearing around the edge here, and then I will cut the piece out with the 2D contour. So adaptive clearing. This I can increase the speed again, 400. Machining boundary, I will choose silhouette. Tools will be outside of the boundary. Rest machining, I actually will do yes from previous operation. So it doesn't cut those holes anymore, it only cut the edge. Ignore cut, I will put 0. retract high, 2, 4. For this one, I want to leave a thin layer at the bottom so the piece doesn't fly away once the part is done cutting. So I will leave about 0.3 millimeter. Tolerance, I want to cut fast, so I just leave it like this. Maximum roughing step down, very slow, 0.4 millimeter. Stock to leave, I will do the same. 0 here. Direction, you can do clamp, I will choose conventional. Minimum retraction. Okay, ram clearance high, I will go very small, 0.4 millimeter, 1 degree, and I click OK. Okay, so it doesn't seem to generate any tool paths. I think I know why. We'll go to edit. Here, I think I will have to add additional offset. I will put 4 millimeter and click OK. Now it is better. Next step, I want to cut the piece out and also smoothen the edge here. I will use 2D contour. Just go very slow. 200 again. Here, plunge rate, I will go even slower because at the bottom here, the bit will have to plunge through the thin layer of aluminum, so it will have more loading on it. So I will go like 60. Contour, select this one. I want to leave some tab, so the tab will be 0.3 millimeter high. Tab distance, I think this is too many, so I will increase it 20, maybe 24. Too little, 24. Yeah, this is about right. 2, 4, 1.5, minus 0.5, multi-depth, 1 millimeter. Okay, everything seems right. Just click OK. Say no, I have to reduce this, 1.5, and click OK. I have a little problem here. I don't see any tab, so I will have to edit the tool path. I think that the tab high here, I put 0.3 millimeter, but here at the bottom high, I put minus 0.5 millimeter. I think I would have to put 0.8 millimeter. That is 0.5 plus 0.3. Now it is exactly what I wanted, so I can export the tool path. Go like this, right click, post process, pause. I have to choose from library. I will search for gerbil. This one, and select. Okay, here save retracts. I prefer to use the clearance high. Even though the machine have the homing setup, I don't like to use the limit switches too much because they are mechanical switch. They can get worn out if you use them too often. So for me, I think I will choose clearance high. Choose the folder. And we go to desktop. select folder, and here I will put just any name, just you can recognize. 90-degree bracket 2020, and I will put 2mm flat end. That's it, and I click post. I'm done. Now let's see how the machine cut this piece out. I don't want the aluminum chips to fly everywhere in my house, so I will use the giant cardboard box that they used to deliver the machine to make the shield for it. I think like this will be good. I have here my stock. This piece of plywood, I will use it as wasteboard. I will use the clamp set that came with the kit, but to make the clamping a lot easier, this is how I set it up. This bolt here, I put it through the hole. It will face down like this, so the bolt head will press against the platform. That way it doesn't damage the platform. This one, I screw in this one first. Put the ring on, slide it through, and here I have a drop-in T-nut M6 3030 series. This T-nut is not included in the kit, but I have a few in my stock, so I want to use it. I put it on like this. Okay. Now I just put the drop-in T-nuts in here in the slot of the platform. Adjust this bolt to the height, and then I can tighten this. Very easy, very tight. Here the single float end mill just came with the kit, 2mm diameter. I just push the spring inside the nut like this. Put the bit inside and tighten the bit with the wrench. Z-probe. Set again Y position, and I just send. The piece seems to be cut just fine. Let me just take it out. As you can see that it will cut all the way through and the piece will hang on to the stock by the tabs. So let me just cut the tab and show you the edge, and also I will check the dimension with the caliper. Everything seems to be cut correctly. The edge here is kind of smooth when you touch it, but it doesn't have the shining effect like polishing. Not like inside the hole. The edges are really smooth and it kind of like have the mirror effect. Let me just try to slide an M5 bolt through to see the dimension were correct. Okay, so I have an M5 bolt here. It slides through all the hole very snugly, so I think the dimension were right. Let me just measure the edge distance here. Look at this, I have the edge almost exactly 60 mm, so the precision of the machine is really good. This piece was cut correctly, but I still noticed some kind of rumbling sound when the machine was cutting aluminum. I don't think that it would have any problem cutting wood or plastic, but aluminum is a lot harder compared to those materials. I think that if you want to have better cut on aluminum, you might need to upgrade the spindle. This spindle is 52 mm, so it's very easy to upgrade to 500 watt spindle and even 800 watt. I think I've seen some 800 watt spindle that have the diameter of 52 mm, so you can slide them in here very easily. For the signal to control the speed, the controller board is ready for that. Let me just show you very quickly. On the controller board, you can see there's a red connector here. It is the PWM signal output, so you can use it to control the speed of the spindle if you want to upgrade. There's also another connector here. I think that's another type of speed controller, but I don't really know it, so I'm not going to say anything for now. I think that this version of 3018 CNC is a big step up compared to the first version of the 3018 CNC Pro. It can cut aluminum a lot faster. If you watch the video when I tried to cut aluminum with my first 3018 CNC, I had to cut very slow, like 0.1 or 0.2 mm step down with 200 mm feed rate, and I had to use compressed air along with water mist to cool down the bit, and it didn't do so well. All the bearings were getting loose. With this machine I was cutting at 0.4 mm step down, 400 mm per minute feed rate, and it was cutting just fine. The bit is still very sharp, so everything went really smoothly. Of course, this machine is a bit more expensive compared to other 3018 CNC, but you don't need any upgrade to cut aluminum, so I think the price is worth it. And if your goal is to cut aluminum, you surely can start with this machine. So if you want to buy it, I put the link in the description of this video.